Hello, everybody, and welcome to video 6 of 6. This is the final video in the series from Coding Academy related to the Bebras and in more detail related to the concept of Python programming and how can we understand and comprehend all this information that we've studied so far and produce one of the most difficult challenges in this series. And that's what we're going to do today. Now, this final video is definitely increasing the level from previous videos. We are going to look at things like modularization, decomposition, creating functions. We're going to go through a couple of examples, and then we're going to hit the challenge, which is definitely the hardest challenge and the longest Python code we're going to write in this whole 6-video series. So let's begin. Modular. What is modular? Well, modular is something that a lot of companies are using now, and one approach that they use this to give you an idea of how this works is related to their production lines. Now, in traditional production lines, just to give you an idea of how this kind of works in coding, in traditional production lines, they used to have the long process here, where obviously you had a start and you had an end, and all your products are coming down this production line. Now, in the past, if something went wrong in your production line, then let's say it went wrong here, there was an error, then your whole production line would stop and the whole process would be down. The company would not be making any products until that whatever was damaged got fixed. Nowadays, the production lines have become more modular. And what that means is essentially they are like this. Each one is a fixed module. And of course, in China, they have robot arms to do specific tasks. So again, this will be the starting point, and this will be the end point. But each one of these are modular entities performing a specific task. And one passes over to 2, 2 to 3, 3 to 4, 4 to 5. What's the difference? Well, this process is not contiguous, which means that they're not all connected together. And so if something goes wrong, let's say here, then all they do is they take out this robot, in this case, they replace it with a new robot, and within the space of 10 minutes, however long it takes to replace that robot, that production line is up and running and flowing again. And that is the basic concept of modularization. It just makes everything a lot easier, simpler to follow. And the whole concept behind this is that it improves code organization, reusability, maintainability. And it makes sure that each part of the code works independently of the others. So another benefit of this is, let's say that we have, as an example, Windows 13 or Windows 14, okay? And because Windows itself is a huge program and very complicated, they usually have different people doing different tasks. So in this scenario, what we could do is we could get programmer 1 to work on the GUI, and we could get programmer 2 to work on the back end, which is the main action part of the code. And they could be working on this simultaneously. And at the end, we could simply combine these two together because they're both two modular entities to work together. And an example of that can be seen here in e-commerce, where we could compose modules into the product inventory, the stock, order processing, payment, and so on. And each one of these work individually and are separate pieces of code. And let's look at the purpose of this. Why do we do this? Well, there's some main points here. Maintainability. It's a lot easier to handle thousands and thousands and maybe hundreds and thousands of lines of code if you have them all modularized and separate. We can also reuse that code a lot simpler. It's definitely easier to debug and test because you don't need to scroll through thousands of lines of code. You can just scroll through each individual component, which maybe only has 50 to 100 lines of code, which is a lot easier for the debugging process. Scalability becomes easier because you can just scale the programs. And the modularization is still the same. You can connect this one to this one to this one, and so on. And we also have something called loose coupling, which basically means if you design the modular programs really well, then they can interact much better with each other without causing any problems. Okay, so if we have a look here at a nice quotation, focus on one thing at a time without distraction. And basically what that means is why focus on many, many lines of code when you could just focus on one thing, do a good job on that, and then move on. That's the concept behind this. Okay, let's move on now to functions. As we know, we've touched on functions before in previous code that we have created, and we're going to look at it again now, because functions is one of the main concepts in modular programming. Let's have a look how they work. On the left-hand side, we are making a program to calculate the area of a rectangle without a function. Okay, and here we set the variables, here we set the formula, which is a multiplication, and then we print it out at the end. If we do that same concept inside a function, then what we can see is that this is our standalone modular function that doesn't change, that's fixed. And actually, if we look here, we have 2, 3, 4. Basically, we have 4 lines of code over here. Over here, we have more lines of code, 2, 4, 6. We have 8 lines of code. But we actually use and call that function 3 times. So you can see that we've basically doubled the lines of code, but we've actually called the function 3 times more. So if we went with the approach of without a function, and we run that 3 times, then that would be 4, 4, 4, which will be 12 lines of code. So already using a function, we have reduced the number of lines of code to just 8, and we've actually called it 3 times. So you can imagine if you have to call this 100 times, 1,000 times, how many lines of code and how much time you're going to save doing that. Decomposition. What is decomposition? Decomposition is something as important as functions and modular programming. And it's where we break down the problem into smaller functions. And this is something that's used in object-oriented programming because we divide the system into individual objects where each object represents its own entity. So this is quite often used in business, in project management, where very simply we take a difficult problem like this and we break it down into smaller problems. And then usually we assign somebody to deal with each one of these problems. And then at the end, we bring all these small problems back together, we bring it back to the original one, and we solve that problem. So what is modular decomposition? Well, this is combining what we talked about before with the modularization together with breaking the problem down into smaller parts. And it's where we organize a program into separate modules. And those separate modules could be the functions that we talked about before. And that's where we get functional decomposition. Breaking them down into nice, simple functions that we can put actually in a separate file within our application, and we can just keep calling and calling as many times as we want without increasing the number of codes, without increasing the number of lines of code in our program. So this is all the concept. And what we're leading on to here is essentially algorithms and using everything that we've talked about, the functions and modularity and decomposition. So let's go straight to a program here. And this program is the score threshold count. Now, let's have a quick look at what we need to do here. This is not one of the challenges yet. Write a program to determine the number of pupils in a class who have scored above a specific threshold. The first line of code contains two integers. The first integer is the total number of pupils, and then we have the score limit. So that would be something like 5 students, and the limit would be 60. The final line of code will be the pupil scores. So this is pupil 1, pupil 2, 3, 4, and 5. And then finally, you need to output how many of those pupils have a score higher than the threshold which we have here. And as we can see, we have this is higher, this is higher, and this is higher, and therefore we have 3 pupils. We're not going to go into great detail with this program. This is basically an activity for you to do on your own as homework. But let's have a look at the decomposition. So if we break this down into kind of steps, which is the process of algorithms and decomposition, we need to think about the flow of the data. We need to take in the number of pupils and the threshold, count and return the elements in a list, iterate over them, so therefore we're probably going to be using a for loop or a while loop here, check the threshold value, how many students are over that threshold value, sum up the results of all the students over that threshold value, terminate the loop, and output the results. I promise you, if you start thinking about your programs and applications with this process in mind of the functions, the modularization and the decomposition and writing an algorithm, you will produce results so much more efficiently and quicker and error-free than you have done before. This really is the flow of professional programming and how we do it. Okay, so I suggest you pause the video now because I'm going to show you the results. We're just going to have a little look at the code. So try to do this on your own first. Follow this algorithm here. And now I'm going to show you the results. So here is the code. And the code, as you will see, literally follows this process where I go through and I literally check every one of these in order to provide a successful program. All right, so let's have a look at this code. Okay, we start on line 1 by taking in input parameters. And in this case, we take in the total number of students, and we also take in the limit, which is a threshold. We store them in input parameters. We split the two values. So let's say we have 5 and 60. Then 5 is going to go into here, which is the num, and 60 is going to go into here. And you can see we do that by using indexing. 0 is the first element in input parameters, and 1 is the second element. Everything in programming starts from 0. We then make a simple variable, which is the total bigger. Of course, you can call these anything you want. This is just what we called it in this case. And then we begin the while loop. Okay, now the while loop is where we're going to read in the list of numbers and process them. And you can see that the while loop goes on all the way to the end. And this is what's called an infinite while loop. Infinite while loops. Because we set it to true. True means 1, and therefore it runs forever. You need to be a little bit careful when you use these, because you have to have that break here. If you don't have that break, then this will never jump out. And at the end, we're going to print the total bigger, which is going to be the number of students above the threshold of 60. Okay, so the while loop starts here, and we're going to start running through it. Let's grab the first one. Enter the next pupil's score. So you're going to enter the value in the score, and then we're going to set a couple more variables, the number processed, number bigger, and then we're going to start a for loop. And that for loop is going to run around to grab the numbers inside that list. It's going to split them down. So let's say we enter 40, 70, 80, 90, and 100. The split, as we've seen many times, it's going to break each one of these numbers down, and we're going to analyze each one of these separately within this for loop. And the first thing we want to do is, if you remember, when we use a split command, it's a string. So we have to put it into a number. And that's what this does here. It's an int, which is called casting, and it converts it into an integer. Then we keep track of the number processed. In this case, we add 1, the number's being processed. And then we check, is this value greater than threshold? If it is, we simply add 1. So this is just a counter. That's all. This is going to run around for however many times you have in your values here. So this is going to run 5 times. Then, once that's finished, it's going to come over here, and it's going to say, the number is minus num processed. So what that's going to do is going to reduce 1 from the number that we entered in the beginning, which was 5. And then total bigger is just going to add the value that we have. So that's just going to keep track of the number we have. Then once the number gets to less than 0, that means that we have gone through them all. 5 minus 1 to 4, 4 minus 1 to 3, and so on. And that is basically the end of the program. It then prints out how many are greater than 60, which in this case should be 4. And that would be your output down here. So quite a challenging program, but hopefully that made it a little bit more easier to follow when you followed the decomposition approach of this. Okay, next one. Let's move on now to a past GCSE coding question. I'm going to go through this one in less detail because the whole idea now is for you to start taking charge of your own coding now and start producing your own results. So let's have a look at the challenge for this one. In this one, you're given a list of integers where you need to check if any consecutive sequence of 5 numbers is in ascending order, each exactly 1 number apart. For example, if we have a sequence like 3, 4, 5, 6, 7, this qualifies, but 3, 4, 6, 7, 8 does not, because there's a missing number here, which is 5. So all you need to do here is to find out that the list has 5 elements. You must have 5 elements at least. And the elements in the list are all integers. So these are some things you need to think about here, where you can count them here to make sure that they make the count of 5. Check that they're all integers here. You can have some error checking in your code. Let's have a look at the decomposition here. So as we talked about a lot, defining a function is pretty much the first place to start when analyzing these sorts of problems. We want to get everything as much as possible into functions. And what you'll find as you get older and as you start to become more advanced with this coding, you will be reusing functions that you've already created from previous programs. And this is where we get the phrase, there's no point reinventing the wheel. Because there isn't. Somebody's already made it. You have already made this. Why should you make it again? So we want to make a program now which has this function. It checks the 5 numbers, give an input list, return true if the 5 numbers are found, false if not, and then iterate over the list. So stop the video now, see if you can produce this problem from over here. This one's a little bit more simpler to follow than the previous one. Try to follow my list here of decomposition, or even make your own. And I'm going to show you the code now, so stop the video. Okay, welcome back. Here is the code for the previous one. You can see that we have our modular function here, declared previously and separate. And the actual code I have is simply just 3 lines here. That's all it is. 1, 2, 3. And that's running this function 3 times. So you can imagine that if you didn't have a function, you would have 1, 2, 3, 4, 5, 6, 7. You would have 21 lines of code to run this 3 times, plus 3 lines here, just to illustrate the absolute benefits of functions. Okay, so what we do here is we print out has consecutive 5. That is the name of the function over here. We pass to it a list. Notice we have brackets for the list, which is here. And that list is now used inside this code. So if it's less than 5, return false and end. In other words, it will not work, it will not function if you don't have 5 elements. If we do have 5 elements, and that's going to skip, it's going to come down here to the for loop, and it's going to start running through this for loop. And the main part of this code is this huge line here. That's all one line. And all it's doing is checking if the number is equal to the next number. Yeah, so this is kind of a check to make sure that 3, whatever we have here, is equal to the next number plus 1. That's why you get 1 here. It's then checking if this number is equal to this number plus 1. That's where we get the 1 from. Okay, so just keep a check on these numbers here, and that will make sure that you have a sequence of 5 numbers, because this is performed 5 times inside here. It's 5 checks. And that's pretty much it. So hopefully you will have time to go through this yourself and check it and produce your own. And good luck with that. And that brings us to the end of the theory part, the discussion part. We're now going to go over to our actual challenge. This is the one we're going to go through in more detail. And also I'm going to give you a chance to try to do this yourself. So you're going to have a chance to stop the video and perform this challenge. This is definitely the most challenging one we've looked at so far. It's called Magic Squares. 2025 Coding Challenge. So if we're all ready, let's do this. Now, this is the algorithm, so to speak, like the decomposition of what we need to do. So let's have a look at the actual challenge first. The challenge is quite an interesting one. We need to make a program that can identify a magic square. What is a magic square? Well, there are obviously criterion for what a magic square is, and that is that it is a 3x3 grid where the sum of each row, column, and diagonal is all the same, which is 15. So this is pretty complicated just to actually find one of these, let alone to write a program to check it. So what we can see here is that we can see 6 plus 7 plus 2 is 15. 492, 15. 852, 15. 654, 15. Everything basically, all the rows, columns, everything adds up to 15. And if it's a 3 by 3 matrix or grid, then that is classed as a magic square. And that is your task. So feel free to stop the video now. You have an actual input, which is magic. So you can check if it works. And if it's not magic, we're going to display the word muggle. Now, as you can imagine, there's quite a few things to check here. And that is things like the rows, do they add up to 15? The columns, the diagonals, and so on. So a couple of areas we need to focus on here. 3 lines of 3 integers separated by spaces. That is the input. Each integer has to be from 1 to 9, obviously. And that's it. Okay, so stop the video now. If you want to have a look at the decomposition in more detail, then I'll show you that now. Here it is. So basically, I've broken it down into what we need to do. And that is, we need to figure out the sum of the rows, the sum of the columns, the sum of the diagonals. So what would be a good idea would be for you to put all those into function. And you could have that returning like true and false. If any of those are false, then it's not a magic grid. Then we can move down to the actual function itself. That is the main function. And we're going to call that is magic square. And that's down here. And this essentially calls the other ones above. If you don't have these in functions, then you can simply have them just like check the row, check the column, check the diagonals here. And if they all sum up to 15, then we're going to return magic. If they don't, we're going to return muggle, and we're just going to print that out at the end. So that is the decomposition of this, the algorithm, so to speak, to follow. Okay, so let's have a look at the question again. Now's the time to pause the video because I'm going to show you the solution, and we're actually going to go through this and write this together. So let's do that. Let's go over to our editor, which is fantastic for this process because it gives us the blocks as well. Let's just go full text in this case. And let's produce this code. So what we're looking for is the main function, and then we're looking for ways of finding the rows, columns, and diagonals. So let's work through that first. I'm going to make a function is magic square, and obviously I need to pass to it the grid. All right, so inside here, we're going to have a check for the rows. So let's check for the rows first. In order to do that, we need to make a list. And then I'm going to go through them all from the grid. Rows dot append. And I'm going to sum the row. That's my first check. Then I'm going to do the columns. Check the columns. So to do the columns, let's call it cols. Make an empty list. Of course, this is one way of doing it. There are multiple ways of performing these sorts of tasks. Don't feel you have to do exactly the way I'm doing it here. Now that's going to be fixed at 3. So it's going to be 0, 1, 2. And let's create another variable, which is going to give us the sum of those columns. We're then going to make what's called a nested for loop, which we did in the previous video. And that is going to be 3 as well. And let's produce the sum of that, which is going to be, I'm going to use shorthand here, plus equals, which is the same as saying col sum equals col sum plus. And I'm going to add the grid from J and I. Because we're accessing the index, we need to have brackets like so. And then at the end of that, we're going to append the col sum. So obviously, because we're talking about the columns, we need to have a nested for loop so as to access each of the columns. Okay, things are looking good so far. We have the rows, which is this one. We have the columns, which is this one. Now we need to check the diagonals. Now there are more than one diagonal, so we're going to need to make 2 variables. Diag1, diag2. And we're going to cycle through those 3 numbers again, which is 0 to 3. Diag1. Again, I'm using shorthand. We're going to access each element. It's going to be II. And diag2 is going to be grid I and 2 minus I. Because we want to get the diagonal numbers, don't we? Okay, that looks great so far. So we now have 3 pieces of code, which, as you can see, they're really neat and tidy, and that so therefore can easily be put into functions themselves. Now all we need to do is check if the sums are correct. So we can go to all sums. Rows plus calls plus diag1 and diag2. And I'm just going to run through these quickly now to see if they're all 15. So I'm going to go through X in all sums. I'm sure that you could do this with less variables as well than what I'm using here. I'm just trying to make it as simple as possible and as clean as possible. Now, if X does not equal 15 in any of those things that we found, so in other words, in any of the rows, in any of the columns, or in the diagonals, then we are going to return what we said, which was muggle. This was from the actual program, which was here. This is the actual question from Bebras. Okay, so return the muggle. And if this doesn't fire, then we are going to return magic, because that means it is. If all these are 15, then it's going to return magic. Now, I don't like using numbers like this inside here. So as an improvement, I think you could probably make another variable, or maybe pass to it the size of the grid, or determine the size of the grid, so that these can be calculated from the grid and you not have to write numbers inside here. All right. So that's the end of the function. Now all we have to do is start the main code, which is going to be grid equals an empty grid. And then we're going to start our own for loop because we need to take in these values, don't we? So we're going to use range again. Let's grab the row from the user. Now in the Bebras, they usually just have this input as empty, but I'm just making some words to make it a little bit easier to follow. And what we can do here is we can actually, let's make a format. Depends on how you do this. I'm going to use the print format string. So that's going to give me I+1. That's going to tell me which row I'm on when I'm printed out. You can obviously do it the opposite way around, where we put dot format at the end. That's also another option. Like this. It's the same thing. You decide what you want to do. So I'm taking in the values there. Then I'm going to make sure indentation is correct. Row list. Row dot split. And I'm going to do a shortened version now of another for loop, which is converting them all to integers. Because I've done a split, I need to convert them to integers. So you could do the traditional way of just running through the for loop like that, but this is a way that we do to make it all in one line, which is really nice. This and close it. So that's like kind of 2-3 lines of code in one single line there. And then we're just going to append the numbers to our list. And that's pretty much the whole code. So the last thing we need to do now is just print we're going to call the function and we're going to pass to it the grid that we've just made, which is here. And providing I don't have any typos, just checking for the code. Now I have one there already. The end. Whenever you have a for or an if, you have to have that semicolon there at the end. I have everything else. It looks pretty good to go. And a good check is to have a look at the blocks. I see that all the blocks are made. That looks good. Got my colon there. Okay. So let's see what happens here. What we want to do is try to produce this one. So we're looking at 816. Let's try and run this. Three, 5, 7. I need to write them down because it's Let me just make a note of these. Every time you jump out, it stops the program. 816.357.492. And again, so 816.357. And you can see at the bottom, enter row number 1, enter row number 2, 492. And there you go, it's magic. Yeah. Just like magic, it produced the result. Nice. So if we change one of those numbers, let's say we change the 5 in the middle to a 3, then that's going to give us completely different numbers everywhere else. Let's see what it gives. 816.337 and 492. And it gives us Muggle. Yes. Nice. Everything works well. And we've now come to the end of video 6 and the end of this series. So the last thing we need to do is just grab all this code, go over to Bebras. This is the last one and it's 8 marks. The other ones were like 4 marks. This is quite challenging, that's why. Paste it in. Make sure my inputs don't have any text. Yep, I've deleted them. There's no comments. Let's submit. And we get a full score. Everything's passed. Well done. And that's it, guys. Thank you for joining me on this series of 6 videos. It's been fun to have you with me. And I hope you've gained a lot from this. That is another successful challenge and another successful program. Take care of yourselves and have a great day. Bye-bye.